Good evening, students. Good evening. So this is the first question we are discussing today. Today we are discussing Newton's laws and kinematics, questions from those two topics. Okay. Now this is the first question. A block of mass m lies on wedge of mass capital M as shown in the figure. Answer following part separately. With what minimum acceleration must the wedge be moved towards right horizontally so that block small m falls freely? That is first bit. And second bit, find minimum friction coefficient required between wedge capital M and ground so that it does not move while block small m slips down on it. So first bit, usually they'll ask question where what should be acceleration of capital M so that small m remains stationary with respect to capital M, with respect to wedge. Okay. In that case, what do you get? The small m should remain stationary with respect to capital M, means it should not slide on capital M. So both small m and capital M should move together as if it is a single block. In that case, acceleration of wedge has to be g tan theta. Acceleration of the wedge has to be g tan theta towards left. Okay. If both of them has to move together, then acceleration of small m with respect to capital M has to be 0. Means net force on small m with respect to capital M has to be 0, and capital M is a non-inertial frame. So before answering this bit, we'll do that. Okay. So that did you follow? G tan theta I'll get. Now in this bit, what they have asked, with what minimum acceleration must the wedge be moved towards right horizontally so that block of mass small m falls freely. Now when this block of mass small m falls freely means what? Its acceleration is acceleration due to gravity, g downwards. That means it should lose contact with capital M. If it has to fall freely, it should lose contact with capital M. Then only it will fall freely, then its acceleration will become g downwards. Means normal force between block and wedge becomes 0. Okay. So what is minimum acceleration of capital M so that it falls freely means it just loses contact. Just loses contact. It is almost on this surface, but just lost contact. Okay. So if I assume acceleration of the wedge now if I assume acceleration of the wedge is a towards right, then what are the forces acting on small m with respect to wedge? Because wedge is a non-inertial frame. Yes, but this is not for those students who have already attended, okay, that class. Same questions I am discussing, that's all. But this is because they are teaching in Hindi, the students here are facing some problem, I think. So we have to repeat same questions here. Okay. So those who have listened already, you need not attend these sessions. Okay. Okay. This we are doing for students here. Now if it's acceleration, all the questions same questions I am repeating, that's already discussed earlier. Now what are the forces acting on small m with respect to capital M? One is pseudo force in this direction because capital M is a non-inertial frame. Normal force will be in this direction, which is 0 in this case, and gravitational force downwards, mg. And if it just loses contact, when two blocks are in contact, then along the normal, their velocities has to be same and accelerations has to be same. So when two blocks are in contact, along the normal, accelerations has to be same. Now they are just in contact. Also, along the normal, their accelerations are same. Okay. So along the normal, what are the forces acting on this with respect to this should be 0. Okay. Along the normal, net force on this should be 0 because it just loses contact. Normal force should become 0. So what is this angle? Now this angle is theta and this is 90 minus theta. And this is also theta. So what is net force in this direction is 0. So net force in this direction means MA sin theta equal to mg cos theta. So what is A? G cot theta, I'll write. G cot theta. So if acceleration of this wedge is g cot theta towards right, then small m will just lose contact with respect to capital M. If it is greater than g cot theta also, it will lose contact. Then its acceleration is g. So if it has to lose contact, acceleration of the wedge should be greater than or equal to g cot theta. They have asked minimum acceleration, means we will write g cot theta. Okay. Next, find the minimum friction coefficient required between wedge capital M and ground so that it does not move while block small m slips down on it. So, when small m is slipping down on capital M, what is minimum friction coefficient required between wedge capital M and ground so that it does not move while block small m slips down on it? So I will assume they did not mention whether there is friction here or not, but I assume it is smooth, but there is a friction between wedge and ground. So what is coefficient of friction between wedge and ground is mu, let us say, mu, and small m is sliding down. Then what is acceleration of small m is g sin theta and capital M should not move. Then what is normal force acting on small m is mg cos theta, mg cos theta, small mg cos theta. Net force in this direction on small m is 0. So net force in this direction, if I equate it to 0, what is normal force we will get? Small mg cos theta. Now if I write down forces on wedge, what are forces on wedge? That is normal force by small m on capital M, which is nothing but small mg cos theta. And other one is normal force by ground, let us say that is N1, and capital mg downwards. So these are the forces acting on capital M other than frictional force between capital M and ground. Now if horizontal component of this normal force, this mg cos theta, horizontal component is greater than limiting friction, this wedge will move. So when this wedge remains stationary, if this horizontal component of mg cos theta is less than or equal to limiting friction, the wedge remains stationary, or limiting friction should be greater than or equal to horizontal component of this mg cos theta. Now if I draw horizontal here, what is this angle is theta, what is this angle? 90 minus theta. So what is the condition this wedge do not move? The limiting friction between wedge and ground should be less than or equal to the horizontal component of mg cos theta, which is mg cos theta into sin theta. So what is the condition? Mu into n1 is less than or equal to mg cos theta into sin theta. But what is n1? We can find net force on the wedge in this direction should be 0. Anyhow, wedge cannot move in this direction. Okay, so n1 equal to capital mg plus component of mg in this direction, that is small mg cos square theta. Okay, so substitute this n1 value here and take it to RHS. So what is minimum coefficient of friction if they ask? We can write equal to directly. Mu should be less than or equal to small mg sin theta cos theta by n1. What is minimum value of mu? then mu equal to mg cos theta sin theta by n1. Okay, followed? Okay. Then we will go to next question. Next is this question. The system shown adjacent is in equilibrium. Find the acceleration of the blocks A, B and C, all of equal masses m, at the instant when assume springs to be ideal, the spring between ceiling and A is cut. Next bit, the string between A and B is cut. The spring between B and C is cut. Also find the tension in the string when the system is at rest and in the above three cases. Okay. Now initially all the three blocks are placed like this and they are in equilibrium, and whenever we cut a string, then tension in that string becomes 0, but tension in the springs do not change immediately. Tension in a spring will change only when their length changes. Length changes when the blocks move. After some time, tension in the string or spring changes, but instantaneously tension in the spring do not change. Tension in strings can change instantaneously. So whenever you cut any string, then tension in other strings will change instantaneously. At that instant, immediately it changes, but tension in the spring do not change. Okay. So initially they are in equilibrium. What is mass of each block? This is small m, this is also small m, this is also small m. Okay. Then what is tension in this spring? If I consider equilibrium of this block, tension in this spring is equal to small mg. Then here tension equal to 2 small mg, tension in this string. Now if I consider these two as system, what is upward force here? Tension, and downward force 2 mg. So what is tension in this string is 2 mg. Similarly, what is tension in this spring? 3 mg initially. So tension in this spring is 3 mg if I consider equilibrium of all the three blocks, and tension in this string 2 mg, and tension in this spring is mg. Okay. Now if you cut a spring, tension in that spring immediately becomes 0. But if you cut other springs, tension in the springs which is not cut do not change immediately, instantaneously do not change. So in this case, first bit what they have given, the spring between ceiling and A is cut. The spring between ceiling and A is cut. Then tension in this spring do not change. Tension in this string will change immediately. But tension in this spring do not change, but tension in this spring becomes 0 because we have cut that spring. Immediately it becomes 0. So what is the figure you will get for first bit? Upper block A and this is B, both same mass, and here another spring. What is mass of this block? M. And now what are the forces acting? If you consider block C, tension in the spring do not change immediately in the first case. What are the forces acting on this block? This is small mg downwards, and here tension is small mg upwards. Small mg upwards. Okay. Because tension in the spring earlier is small mg, even if you cut this spring, tension in the spring do not change immediately. Okay. So what is net force acting on block C? 0. So immediately after you cut this spring, acceleration of block C will be 0 only. Okay. But we will see, consider these two blocks. If I consider these two blocks, what are the forces acting on B? One is gravitational force, other is tension in the spring which is mg downwards, and other is tension in the string, let us say T upwards. Then what are the forces acting on this block? This is mg downwards and T downwards. Okay. Now if you consider these two as system, one block is below, other block is above, and this string is tight just before this is cut. Now will it remain tight now? After this spring is cut, this is the position. Next moment, will this string remain tight or will it become loose? Now if I consider this block, What is total downward force acting other than this tension? 2 mg. If I consider this block, small mg. So if I consider individually this block, its acceleration will be 2g. If I ignore this string, its acceleration is g. So its acceleration is greater than acceleration of this block. So if you connect them by a string, this string remains tight because it will pull this block along with itself. Okay. So if I release two blocks like this, A and B, they are connected by a string, and there are some forces acting on A and B other than gravitational forces, let us say, in vertical direction. Then when will they move together in downward direction? If they have to move down, when will they move together in downward direction? If acceleration of block A in downward direction is greater than the acceleration of block B in downward direction, if there is no string, whatever forces are acting on this, if net force downwards will produce some acceleration in it, on this also net force downwards will produce some acceleration. So if its acceleration is greater than this, then they will move together if I connect them by a string with same acceleration. Okay. But if its acceleration is greater than this, when there is no string, then even if you connect them by a string, then the string become loose because it comes down faster when compared to this. So next to moment string has to become loose. Okay. So in this case, what is its acceleration if there is no string? Will be 2g, because 2 mg is acting downwards. What is its acceleration if there is no string? G downwards. So if there is a string in between, they will move together. Okay. So I can consider these two as a single block now because they are moving together. Then what is acceleration? Net downward force by total mass. What is net downward force on the system of these two blocks? Here 2 mg, here mg, that is 3 mg by total mass 2m. So 3 mg by 2m, that is 3g by 2. So that is combined acceleration of A and B. That is combined acceleration of A and B. So immediately after the spring is cut, accelerations of these two is 3g by 2 and acceleration of this block is 0. Now how do you find tension in this string? Take any one block, either A or B, and write down force equation. If I take A, what are the forces acting now? Mg downwards, T downwards. So what is the force equation I will get? T plus Mg equal to Ma. Ma, what is A? 3g by 2. So 3 mg by 2. So what is tension I will get? Mg by 2 will get. Tension is Mg by 2. So what is tension in this string? Is Mg by 2. Followed? Any doubt? Now next bit, the string between A and B is cut. Now this is cut. Immediately after this is cut, the tension in this spring and tension in this spring do not change. This is cut. So tension in this string becomes 0 immediately, it becomes loose. But tension in this spring and tension in this spring do not change. Okay. So if I consider block A now, what are the forces acting on block A? What is tension in this spring before this string is cut is 3 mg. Now also it remains 3 mg. So spring will apply how much force on this? Is 3 mg in upward direction. And what is the other force acting on this? Mg downwards, because this string is cut. Only gravitational force. So what is net force acting on this block? Is 3 mg minus mg, that is 2 mg upwards. So what is its acceleration? Will be 2g upwards. 2g upwards. Okay. Now if I consider these two blocks, block B and this spring and block C. What is tension in this spring? Is mg initially. Even if you cut this spring, tension in this string, tension in this spring immediately do not change, it will be mg only. So what are the forces acting on this block? Mg downwards and upwards, mg upwards. So this also no acceleration at that instant. Okay. Next, what are the forces acting on B? Mg downwards and gravitational force mg downwards. Spring force is mg downwards, gravitational force is mg downwards. So what is net force? 2 mg downwards. So what is its acceleration? 2g downwards. And tension in the string is 0 in the second case, because that string is cut, tension cannot be there. So what is the answer for second bit? Acceleration of block A is 2g upwards and acceleration of block C is 0 and acceleration of block B will be 2g downwards. Okay. Now, if I see C bit, the spring between B and C is cut. The spring between B and C is cut, then immediately tension in this spring becomes 0. Okay, but tension in this string can change immediately. Tension in this spring should not change immediately. Now, what is the figure for third bit? This spring will be there and A will be there and B will be there. Okay, this spring is cut. So, block C, this spring is cut. Now, block C is falling freely under gravity. So, what is the acceleration of block C? G downwards. The third case. Now, we consider A and B now. What is tension in the spring? Do not change. Just before the spring is cut, what is tension here? 3 mg. Just after the spring is cut also, tension here remains 3 mg. So, what is tension in the spring? Is 3 mg upwards. And if I consider these two as system, what is net downward force? Is 2 mg. That is gravitational force. Okay. So, how do you find acceleration of these two blocks? Is net external force by total mass. What is net force in upward direction? Is mg. 3 mg minus 2 mg. Because they are connected by a string, they will move together unless the string is loose. Okay. So, what is acceleration? 3 mg minus 2 mg, that is mg by total mass is 2m. So, that is g by 2l. So, what is acceleration of these two blocks now? G by 2 upwards. Now, how do you find tension in this string? Now, you write equation individually for any one block. So, if I take block B, what are the forces acting? Tension upwards, mg downwards. And what is its acceleration? G by 2 upwards. So, what is the equation we will write? T minus mg equal to m into g by 2. So, what is T? 3 mg by 2. What is tension in this string? In the third case, 3 mg by 2. And acceleration of these two blocks is g by 2 upwards, they are moving together, and acceleration of this freely falling, that is g downwards. Okay. Any doubt? Now, next question. This is the question. Two horizontal blocks each of mass half kg are connected by a massless inextensible string of length 2 meters and placed on a long horizontal table. The coefficient of static and kinetic frictions are shown in the figure. Initially, the blocks are at rest. If the leading block is pulled with a time dependent horizontal force F is equal to kT, where k is 1 Newton per second, determine the plots of acceleration of each block with time from t equal to 0 to t equal to 10 seconds. Okay. Plots of acceleration of each block with time from t equal to 0 to t equal to 10 seconds. That is first bit. Next, velocity of blocks at t equal to 10 seconds. Next, distance traversed, that is not distance traversed by the blocks in the time interval t equal to 0 to t equal to 10 seconds. If F stops acting at t equal to 10 seconds, find after how much time further would B collide with A. Okay. Now, in the first case, let us say if I apply some force on two blocks which are connected by a string and there is a friction also. If there is no friction, whatever force you apply on one block, both the blocks will move together with same acceleration. And how do you find that acceleration? Is this force by total mass. Good evening. If you have any doubt also, you can post there. You are not following anywhere. Now, if friction is there, when these two blocks move, first of all, when this applied force in horizontal direction is greater than sum of the two limiting frictions, then only it will move. Okay. when applied force is greater than sum of the two limiting frictions, then only it will move. But once it starts moving, kinetic friction acts. And what is normal force here will be mg. Here also normal force is mg because all the applied forces are in horizontal direction. So what is limiting friction here? What is mass of each block? Half kg. Mass of each block is half kg. Means what is normal force? 5 Newton. Here 5 Newton, here also 5 Newton. So what is limiting friction between first block and ground? Limiting friction is 5 into 0.6, that is 3 Newton, and kinetic friction is 2 Newton. Okay. Now here, what is normal force? 5 Newton only because both blocks half kg. Then what is limiting friction? 5 into 0.4, that is 2 Newton. And what is kinetic friction? Is 1 Newton. 5 into 0.2, that is 1 Newton. Okay. Now, when these two blocks will move, if you apply this force, when this force is greater than sum of the two limiting frictions, then only it will move, otherwise it won't move. What is sum of the two limiting frictions? 5 Newton. And what is applied force? Applied force is not a constant force, it is varying with time. So F is equal to kT, that is the applied force in the horizontal direction, where K is 1 SI units. Okay. So F is directly proportional to time, F is equal to kT. So when this block starts moving, only when this applied force becomes 5 Newton it starts moving. Okay. So what is time after which it starts moving? F is equal to 5. Then T equal to 5 seconds. T equal to 5 seconds. So after 5 seconds this block starts moving. So until 5 seconds acceleration is 0. And what type of friction acts at both the blocks? Static friction. And when they are just about to move, it is limiting friction. Okay. What is it? Mirrors 3 you have written. Kt equal to sum of two limiting frictions you should write, not sum of two kinetic frictions. Okay. Not 3, it is 5. Both the blocks start moving only when applied force is greater than sum of the two limiting frictions. Equal to limiting friction, they are just about to move. Okay, they are just about to move. So what is sum of the two limiting frictions? Is 5 Newton. So these two starts moving only when Kt equal to 5. K is 1 they have given, so T equal to 5 seconds. So at 5 seconds they start moving, and once they move, after 5 seconds they move, then what type of friction acts? Is kinetic friction. At both surfaces it is kinetic friction. So how much friction acts here? 2 Newton. How much friction acts here? 1 Newton. Then what is acceleration now? Acceleration is net force by total mass. What is net force? Is applied force minus sum of two kinetic frictions. Sum of two kinetic frictions. What is applied force? Kt minus sum of two kinetic frictions is 3 by total mass. What is total mass? Is 1 kg. That's all. So what is acceleration after 5 seconds? Is Kt minus 3. Before 5 seconds 0. So what is first bit? The plots of acceleration of each block with time from t equal to 0 to t equal to 10 seconds they are asking. Okay. So at 10 seconds what they have done? Block in time interval 0 to 10 seconds. Okay. 0 up to 10 seconds. So what type of graph here? Acceleration of both the blocks will be same anyhow, up to 10 seconds. So up to 5 seconds it is 0. So the graph is along x axis. Then immediately after 5 seconds what is acceleration? Kt minus 3. So at t equal to 5 seconds what happens? There is an acceleration. There is an acceleration, and acceleration increases. So there is a discontinuity in the graph. Just before 5 seconds they are stationary, but just after 5 seconds they have acquired acceleration already. Okay. So what is initial acceleration? Immediately after 5 seconds means Kt means 5 minus 3 by 1, that is 2 meters per second square. So the graph starts from 2 meters per second square, and goes on increasing like this. And at 10 seconds, what is acceleration? T equal to 10 seconds if you put 10 minus 3, 7 meters per second square. Okay, followed. At 10 seconds, that is acceleration, 7 meters per second square. Okay. Now, how do you find velocity of the block at t equal to 2 seconds? Velocity of both the blocks at t equal to 10 seconds. Acceleration you know, which is varying with time as shown from 5 seconds onwards. Then you should write acceleration as dv by dt. So, dv by dt equal to kt minus 3. So, dv equal to kt minus 3 into dt, where k is 1 anyhow. Now, you have to integrate to find velocity. You have to integrate as velocity varies from 5 to 0 to v and time varies from 5 to 10 seconds. 5 seconds to 10 seconds, because this equation is valid from 5 seconds onwards. Okay. Then we'll get velocity. Okay. Velocity after 10 seconds you'll get. How much you'll get is see once. K is 1. So, if you integrate this, what do you get? T square by 2 minus 3t. T square by 2 minus 3t. From 5 to 10. If you substitute upper limit, what do you get? 100 by 2, that is 50. 50 minus 30, that is 20. Minus, if I substitute lower limit, this is 25 by 2, that is 12.5. 25 by 2 is 12.5. Minus 15, that is minus 2.5. So, it will become plus 2.5. So, that is 22.5 meters per second you will get. So, what is velocity after 10 seconds? It is 22.5 meters per second after 10 seconds. Okay. Calculation you have to see once again. Okay. First upper limit you have to put and then minus lower limit. Any doubt? Now, next, displacement or distance travelled by each block between 0 and 10 seconds. Now, how do you find distance travelled? You have to integrate velocity. You have to integrate velocity. For that, you have to write velocity as a function of time. For that, you have to integrate velocity from phi to t, generals. After t seconds, what is velocity? Let us say v. So, general function you should write, velocity as a function of time. So, integrate this from phi to t, phi to t. Then what are the limits? If I put phi to t, if I put upper limit t square by 2 minus 3t, I will get. And if I substitute lower limit, that is 5, we have got minus 2.5. So, I will get plus 2.5. So, this is velocity as a function of time. So, t equal to 5 seconds, velocity has to be 0. Okay. So, this is velocity as a function of time. Then how do you find displacement? You have to integrate velocity with respect to time from 5 to 10 seconds. So, displacement is nothing but t square by 2 minus 3t plus 2.5 from 5 to 10 seconds, 5 seconds to 10 seconds. Okay. You have to integrate. So, substitute upper limit minus lower limit, you will get displacement in 10 seconds. First 5 seconds they are not moving, between 5 seconds and 10 seconds they are moving together. Okay. Next, if f stops acting at t equal to 10 seconds, find after how much further time would B collide with A. Now, f stops acting, but at that instant after 10 seconds, what is velocity of each block? Is 22.5 meters per second, which I assume it as u. Okay. So, I will take next page. So, at that instant after 10 seconds, what is velocity of each block? Is 22.5. That is u, let us say. So, for this also u. Okay. Then that F stops acting and there is a string between them. And what is length of the string? It's 2 meters. So distance between these two is 2 meters. And what is kinetic friction here? 1. Kinetic friction here is 2. So frictional force here will be acting in this direction, that is 1 Newton, and frictional force acting in this direction on this 2 Newton. And what is mass of each block? Is half kg, I think. Okay. Mass of each block is half kg. Okay. Now friction is acting on this 1 Newton towards left and 2 Newton on this. Mass of each block is half kg. Now there is a string between them. What happens next? Can anybody tell? Will string become loose or it remains tight and both of them move together? Now in this case there is a string between them. So if string has to remain tight, then its acceleration, if there is no string, its velocity should be greater than its velocity. Then it will pull that. This block will pull this block along with it. Okay. So in this case its retardation is greater than its retardation. Because how much force is acting, retarding force on this block? 2 Newton. Then what is its retardation towards left? Is 4 meters per second square. 2 by half. What is its retardation? Force is 1 Newton, retarding force. Mass is 1 kg. So what is its retardation? Is 2 meters per second square. And both of them have initially same velocity, but this is retarding more. So next to moment what happens? Its velocity decreases more when compared to this block's velocity. So this will travel more distance when compared to that block. So the string immediately become loose. Next to moment the string immediately become loose. Then question asked is after what time this block collides this? Then they will move with this acceleration. This will move with this retardation. This will move with this retardation. Okay. So you can assume after what time this collides. You can take relative motion or you can directly do also. If I take relative motion of, let us say this is A, this is B. What is given? Okay. This is A given in the question. Okay, this is B. Okay, write like that only. Now, if I consider relative motion, what is initial velocity of B with respect to A? Is 0. Relative velocity. What is acceleration of B with respect to A? Is 2 towards right. Acceleration of B with respect to A is 2 towards right. What is acceleration of B? Minus 2. Acceleration of A? Minus 4. What is acceleration of B with respect to A? Is minus 2 minus of minus 4, that is plus 2. So it is 2 meters per second square. I can use relative motion provided until they collide, none of the two blocks has to stop. Okay, that also we have to check when you are using relative motion. Okay, and now displacement should be 2 meters. Displacement of this block with respect to this is 2 meters. And time, asking time, I think. Find after how much further time. Okay, that's time you have to. So use S is ut plus half a d square. So use S is ut plus half a d square. What do you get? 2 is equal to half into 2 into t square. Okay. Relative acceleration is 2 into t square. Okay. So what is t? Root 2 seconds. After root 2 seconds, this block will collide this. But you have to check within that root 2 seconds, this block should not stop. Now this is stopping after what time? Because its retardation is minus 2 and initial velocity is 22.5. It will stop after a time of 22.5 by 2 seconds. And this will stop after a time of 22.5 by 4. So both times, or this time you have to check usually, this will stop in lesser time. That is also greater than this root 2 seconds. So this is colliding this before it stops. Okay. So this is the time after which this block collides this. Root 2 seconds measured from 10 seconds. Okay. Followed. Now this question. Next question. This is from friction. 3 blocks. A system of masses is shown in the figure with masses and coefficients of friction indicated. Calculate the maximum value of F for which there is no slipping anywhere. That is first bit. Second bit, the minimum value of F for which B slides on C. The minimum value of F for which A slips on B. Okay. Now in such problems, what you should do? When force is applied on the middle block. Okay. So when 3 blocks are there or 2 blocks are there, whatever it is, we have applied force on the middle block. And if that force is greater than, and all the blocks are initially stationary, they are at rest. So if force is applied on middle block, and if that is greater than the limiting friction between lower block and ground, then all the blocks will have to move. They will accelerate. All of them will accelerate. They may accelerate together depending on the value of F, or they may not accelerate together. And 2 blocks may accelerate together and third block may not accelerate. Okay. So in such problems, how to find whether they are accelerating together or any 2 blocks are accelerating together, like that. Now if I apply force on middle block, that is B, then block A and block C are accelerated by frictional force. And all the blocks, if at all there is an acceleration, they should accelerate in the direction of external force. So you applied force on B towards right. The acceleration of B should be towards right if at all there is an acceleration, and similarly for A and C also it should be towards right if at all they have an acceleration. Okay. Block A is accelerated by the frictional force between A and B. Let us say frictional force between A and B is F1, and frictional force between B and C is F2, and frictional force between C and ground is F3. Then the frictional force between C and ground always acts opposite to the direction of external force applied if they are initially stationary. So if you applied force towards right, this friction will act towards left. Now block A is accelerated by F1. Block C is accelerated by F2. So A and C, on which we did not apply force, they will accelerate by frictional forces. And frictional force cannot have an acceleration more than frictional force cannot have a value more than a particular value, which is called limiting friction. Means acceleration of A and C has an upper limit. A can be accelerated only by this frictional force. So if this friction is maximum, its acceleration is maximum, then its acceleration cannot be more than that. Similarly, when F2 is maximum, acceleration of C will be maximum, and its acceleration cannot be more than that. So what is the maximum acceleration of the blocks on which force is not applied? You have to find. Now for example, what is limiting friction here? What is normal force? 200 into 0.1. So what is limiting friction here? Is 20 Newton. Okay. So friction, how much it can act here? Less than or equal to 20. Next, what is limiting friction here? Normal force here is 500 and mu is 0.2. So limiting friction here is 500 into 0.2. That is 100 Newton. And similarly, what is normal force here? 90 Newton, 900 Newton. So what is limiting friction here? 90 into 10, 900. If I assume G 10 meters per second square, 900 into 0.1, that is 90 Newton. So limiting friction is 90. Okay. So when its acceleration is maximum, assume acceleration of block A is A1, let us say. Acceleration of block B is A2. Acceleration of block C is A3. Acceleration of block A is maximum when F1 is maximum. F1 on block A will act towards right. On the blocks on which force is not applied, they are accelerated by frictional force in the direction of applied force. So on this, only horizontal force acting is F1, that should act towards right, and both frictions on B will act opposite to direction of applied force. So both F1 and F2 will act towards left on block B, and on block C, F2 will act towards right, F2 accelerates block C, and F3 will act towards left. Okay. Now what is maximum acceleration of block A? When F1 is maximum, its acceleration is maximum. So what is maximum acceleration of block A? Is maximum friction here by its mass, that is 20 by 20, that is 1 meter per second square. So you should find maximum acceleration of the blocks on which force is not applied. Similarly, what is maximum acceleration of block C? When F2 is maximum, its acceleration is maximum. On block C, F2 will act towards right and F3 will act towards left. And what is maximum value of F2? 100, and this is 90. So if maximum value of the limiting friction here, if it is greater than limiting friction between lower block and ground, then only it can move, otherwise lower block cannot accelerate. Okay. So in this case maximum value of F2 is 100 and this is 90, so this block can accelerate. So but what is its maximum acceleration? When F2 becomes 100, its acceleration is maximum. So when F2 is 100, this will be 90, then what is net force? 10, mass is 40, so what is maximum acceleration of lower block? Is 10 by 40, that is 0.25 meters per second square. So in all such problems you have to find maximum acceleration of the block on which force is not applied. So in this case A and C. So which has lesser maximum acceleration? C. So until this acceleration, all of them will move together. For example, let us say acceleration is 0.2. Acceleration is 0.2 means what? Here friction is acting less than 20. Acceleration is 0.2 means what? Friction here acts less than 20. If it is 20, its acceleration should be 1. So if acceleration is less 0.2, friction here is less than 20. Less than 20 means what? It is static friction. Means these two surfaces are moving together. Similarly, if its acceleration is 0.2, means here also static friction is acting. If friction here is 100, its acceleration has to be 0.25. If it is 0.2 means what? Friction here is less than 100. Less than limiting friction means what? Static friction. Means these two surfaces also should move together. So all the three blocks will move together until acceleration is 0.25 meters per second square. Okay. Once it is greater than 0.25, these two will move together, because this block cannot have an acceleration more than 0.25 meters per second square. So it is greater than 0.25 if acceleration, if this force is in such a way, acceleration is more than 0.25, then these two will move together. But this block do not move along with those two blocks. Then what type of friction acts here? Kinetic friction. Then its acceleration will be constant if both the mu s and mu k are same. Okay. Now until 1 meter per second square, what is maximum acceleration of upper block? 1 meter per second square. Until 1 meter per second square, A and B will move together. Then once acceleration is more than 1, which is not possible for these two blocks, then all the three will have different accelerations and everywhere kinetic friction. So until 0.25 meters per second square, everywhere static friction except here between lower block and ground, and all of them are moving together. Between 0.25 and 1, these two are moving together, but this block has a different acceleration from block B. So these two are not moving together. So here kinetic friction, here also kinetic friction. Once it is greater than 1 meter per second square, everywhere kinetic friction, then these two accelerations are fixed and middle block will have an acceleration more than 1 meter per second square. That's how we should do 3 block problems. Okay. Now we will see the maximum value of F for which there is no slipping anywhere. There is no slipping anywhere. Means anywhere there is no slipping. Means lower block should also not move on ground. Then as long as they are moving together, until what acceleration they will move together? Until 0.25 meters per second square. We can assume them as a single block. Okay. So if we assume them as a single block, what is total mass? 90 kg. Then what is the external force we applied? Only F. And this force become internal, this force become internal, this will become external. So when this block move, unless this is greater than 90 Newton here, the block do not move. Okay. So what is first bit answer? The maximum value of F for which there is no slipping anywhere. Means F should be less than or equal to 90, there is no slipping anywhere, none of the blocks will move. So maximum value of F so that there is no slipping anywhere is 90 Newton. Okay. Now second bit, the minimum value of F for which B slides on C. Now minimum value of F so that B slides on C. When there is a relative motion between these two, when acceleration of the system exceeds 0.25, the maximum acceleration of block C, there will be a relative motion between these two. Then B slides on C. So until then we can consider all the 3 blocks as a single block. So until what acceleration all the 3 blocks move together? Until the maximum acceleration of block C, which is lesser when compared to block A. If maximum acceleration of block A is lesser than block C, then that acceleration you should take. Until then they will move together. Until lesser maximum acceleration, which of the blocks have lesser maximum acceleration, until that acceleration all the 3 blocks will move together. So in this case it is 0.25. 0.25. If I apply more than 90, what happens? They will accelerate together. until acceleration become 0.25. So as you go on increasing this force, acceleration of the system also increases until it becomes 0.25, they move together. So what is the maximum value of F for which all of them move together until acceleration become 0.25. So take acceleration 0.25 and find F. And what is the other force acting here? Is kinetic friction here 90 Newton. And what is the equation I will get? F minus 90 equal to 90 into 0.25, that is 22.5. 90 by 4 is 22.5 plus 90, that is 112.5 I will get. So between 90 Newton, as this F is between 90 Newton and 112.5 Newton, all the three blocks are moving together with an acceleration ranging from 0 to 0.25 meters per second square. And once this become 112.5 Newton, all the three are still moving together with an acceleration of 0.25 meters per second square. Any force greater than 112.5, then these two will move together from that onwards, but this is not moving along with B. So there is a slipping between B and C, but acceleration of C will remain constant afterwards. So once this force is greater than 112.5, what type of friction acts here? Kinetic friction, means friction here is constant. So block C will have a constant acceleration. Okay. Now next bit, the minimum value of F for which A slips on B. Minimum value of F for which A slips on B. Now you go on increasing this force from 112.5. What happens? These two will move together as a single block until acceleration become 1. These two will move together. Now you consider these two as system, 20 kg and 30 kg. If I consider these two as system, what is total mass? 50 kg. Until what acceleration I can consider these two as single block? Until acceleration become 1 meter per second square. So take it as a single block. What is the external force acting? F towards right, and friction between 30 and 40 is towards left. So if this F is greater than 112.5, what type of friction acts here? Kinetic friction. How much is it? 100 Newton. So these two blocks I can take it as a single block as long as acceleration do not exceed 1 meter per second square. So what is the minimum value of F so that they move together? Take acceleration as 1 meter per second square and find F. Then what is the equation you will get? F minus 100 equal to 50 into 1. What is F? 150 Newton. So between 112.5 and 150 Newton, these two are moving together as a single block, but its acceleration is 0.25. But these two are moving together with an acceleration ranging from 0.25 to 1. And once this force become more than 150, all the three blocks will have different accelerations. Then upper block and lower block will have constant acceleration, that is 1 meter per second square and 0.25, but middle block acceleration varies with that force. Okay, it will be more than 1. Any doubt? Okay, so next question we will see. A smooth right circular cone of semi-vertical angle alpha equal tan inverse 5 by 12 is at rest on a horizontal plane. A rubber ring of mass 2.5 kg which requires a force of 15 Newton for an extension of 10 centimeters is placed on the cone. Find the increase in radius of the ring in equilibrium. Now a rubber ring of mass 2.5 kg which requires a force of 15 Newton for an extension of 10 centimeters, means what is spring constant of that string? Is 15 equal to kx. 15 equal to kx, k into 0.1. So what is k? 150 Newton per meter. Okay. So such a string is kept on a cone whose semi-vertical angle is alpha. Placed on a cone from here, then somewhere here it becomes tight. Then what is extension? Increase in radius they are asking. Then here tension develops here. It slides down and in equilibrium tension develops. Now what are the forces acting? If I consider any small element on this ring, if this is a ring, you consider a small element on the ring, let us say its length is dl. This point is A, this point is B. then tension in the ring is T, let us say. Tension in that string is T because of elastic forces, because it elongates. Elastic forces come to bring it back to natural length. Okay. So at B, tension everywhere is same. Let us say tension is T. At A, force due to tension will be along the tangent here. At B also, it is along the tangent pulling force. On the small length, what is net force due to tension? If it subtends an angle, d theta at center. Then if tension here is T and tension here is T, number of times such question will come. So tension is in this direction, tension is in this direction at A and B. We have considered a very small arc. What is length of that arc? dl is r d theta, where r is radius of the ring. Then this angle is d theta. Then what is net force towards center? T sin d theta by 2 plus T sin d theta by 2, which can be written as T d theta. So if tension in the ring is T, then what is net force towards center on the small element is T d theta. T d theta. Okay. Now if I consider this figure now, you have considered a small element of dl. We have considered a small element dl. Okay. Then what are the forces acting on that small element? One is, if tension is T, T d theta is in this direction. Then gravitational force is downwards. That is how much? dm into g, that small element mass into g. What is mass of that small element? Lambda r d theta, where lambda is mass per unit length into g. Okay. Mass is given by 2.5 kg. What is lambda? M by 2 pi r. Okay. And what is the other force acting? Normal force. Okay. These are the forces acting on that small element we have taken. Because that ring becomes horizontal, T d theta will be towards center. Okay. Then because it is in equilibrium, what is net force acting on that small element will be 0. Then we resolve them along the tangent and equal to 0. What is this angle? 90 minus alpha. This angle is alpha. So what is net force along the tangent? Component of T d theta in that direction. That is T d theta sin alpha is equal to lambda r d theta into g. So d theta cancels. So what is T? Lambda is m by 2 pi r. What is lambda r? M by 2 pi. Lambda r is m by 2 pi. So what do you get? mg by 2 pi sin alpha into cos alpha. Okay. Net force along the tangent is 0 along the slant height. So what is component of T d theta in this direction? T d theta into sin alpha, and this is lambda r d theta into g into cos alpha. Okay. So here cos alpha. So you will get mg by 2 pi cot alpha. Okay. So if tension is so much, what is elongation? You have to find. If tension is 15 Newton, then elongation is 10 centimeters. So if tension is so much, what is elongation? You can find. What is the mass given? 2.5 and the g is 10, then 25 I will get. 25 by 2 pi into tan alpha is 5 by 12, so that is 12 by 5. So 25 by 2 pi into 12 by 5. Okay. So 5 and this is 6. So 30 by pi I will get Newton. What is tension? 30 by pi Newton. Then what is increase in radius? They are asking only increase in radius. If original radius is r, what is increase in radius? Delta r. Okay. So if it is 15 Newton, what is tension? 30 centimeters. Okay. If it is 30 by pi Newton, what is tension? It is 2 by pi times greater. Two by pi times greater. Okay. 2 pi won't be there, I think. mg by 2 pi. What is tension? mg by 2 pi into cot alpha. Lambda r. Okay. What is lambda r? Is m by 2 pi. Oh, that's correct. That's what I'll do. Followed? But what is increase in radius? This is increase in length, okay. Whatever you are finding is increase in length. What is increase in length? What is actual length is 2 pi r. What is increase in length? 2 pi into dr. So what is increase in radius? Is 2 pi into dr by 2 pi. Okay. So you should divide this with 2 pi. Now 30 by pi Newton force is there. If it is 15 Newton, elongation is 10 centimeters. If it is 30 by pi, what is elongation? Force is 2 by pi times, okay. So 2 by pi into 10 centimeters, that is 20 by pi centimeters. That is increase in length. But what is increase in radius? Is increase in length by 2 pi. Okay. Now next question. A train takes 2 minutes to acquire its full speed 60 kilometers per hour from rest and 1 minute to come to rest from full speed. If somewhere in between two stations 1 kilometer of the track be under repair and the limited speed on this part be fixed to 20 kilometers per hour, find the late running of the train on account of this repair work, assuming otherwise normal running of the train between the two stations. Okay. Say train goes from one station to other station and it takes 2 minutes to acquire its full speed of 40 minutes from rest. So what is acceleration? Is 60 by 2. Not exactly like that, we have to change units, okay. This is 60 kilometers per hour, that is 2, but doesn't matter. 60 by 2 T1L, right? What is T1? 2 minutes. Okay. And from rest and 1 minute to come to rest from full speed, then that is retardation. What is retardation? 60 by T2, where T2 is 1 minute. So this is maximum retardation and this is maximum acceleration. Okay. So it should accelerate up to 60, then moves with constant velocity, then retards and stops at station B. But in between a 1 kilometer track is under repair where speed cannot be more than 20. Okay. So actually if it has run at full speed, the 20 kilometers per hour, okay, full speed of 60 kilometers per hour during that 1 kilometer, how much time it would have taken? That 1 kilometer track is AB, let us 1 kilometer. Then if there is no repair work, it could have travelled with 60 kilometers per hour. Then what is the time it could have taken? Is 1 by 6. 1 by 6 hours. But now because it is going with 20 kilometers per hour, what is the time it will take now? 1 by 2. 1 by 20. This is 1 by 60. 1 by 20. One by 20 hours, okay. So it will take more time to cross this, but before reaching point A, brakes has to be applied and it should be retarded from 60 to 20. So if it has, let us say in between, we consider some point C and point D afterwards. Then at C its velocity is 60 and at D also it will acquire 60. But by the time it comes to A, its velocity should become 20 kilometers per hour. So from here to here it should retard. If it has traveled with 60 kilometers per hour, it will take less time when compared to when its velocity decreases from 60 to 20 here. So here there is some time lag. Similarly here also, if there is no repair from here to here, it would have traveled with 60 kilometers per hour, but now its velocity should be increased from 20 to 60 with an acceleration. So it will take here also more time. So already here there is a time gap, and here also there will be a time gap, here also there is a time gap. Okay. Now from here to here, how much time it will take now? If it retards from 60 to 20. 60 to 20. Now how much time it will take? Now from 60 to 0, how much time it is taking? 1 minute. That is the maximum retardation. It is taking 1 minute. From 60 to 20 means what is change in velocity or decrease in velocity is 40 kilometers per hour. Okay. So it will take how much time? 2/3 minutes. 60 to 0, if it takes 1 minute, 60 to 20 change is 40. So it will take 40/60, that is 2/3 minutes. So from here to here, how much time it has taken? 2/3 minutes now. Okay, 2/3 minutes. Now similarly from here to here, it should accelerate from 20 to 60. From 0 to 60, it will take 2 minutes if it is accelerating. From 20 to 60 means change is 40. Then how much time it will take? It is 40/60. Time taken will be more. Okay. So 60/40. Here 3/2 minutes. Okay. Now from 60 to 20, what is change in velocity? 40 kilometers per hour. Okay. 40 kilometers per hour means it will take from 60 to 0, it will take 1 minute. Okay. From 60 to 20, how much time it will take? 2/3 minutes. Okay. Now here also it should accelerate from 20 to 60. 20 to 60. From 0 to 60, how much time it will take? 2 minutes. Means its change in velocity is 60. It will take 2 minutes. From 20 to 60 means you can use V equal to U plus 80 and whatever it is. You can do by graph also. 20 to 60, what is change in velocity? 40 kilometers per hour. Then how much time it will take? 20 to 60. Change is 40. Okay. So 40/60 into 2, that is 4/3 hours. So from here to here, how much time it will take? 4/3 hours. Okay. From here to here, 4/3 minutes. Okay. And from here to here, 2/3 minutes. Okay. Is it minutes or hours? Whatever is given. This is 2 minutes only. Okay. So this is 2/3 minutes and this is 4/3 minutes. Okay. 1/60 hours means this is 1 minute. And this is 1/20 hours, that is 3 minutes. And now, otherwise what could have happened? Entire distance A to D, if there was no repair, it could have travelled with 60 kilometers per hour only, continuously. Now A to B, what is the distance? A to B, what is the distance it has travelled now? It has retarded. A to B is 1 kilometer only. C to A, what is the distance? From 60 to 20. Okay. 60 to 20. So what type of graph we will get? We plot the graph and see. We plot the graph, its velocity decreases from 60 to 20. Then it remains constant for 1 kilometer. Then increases from 20 to 60. Okay, this is the graph. Then what is this time? It's 2/3 minutes. And what is this time? 4/3 minutes. So what is this distance? Is area of this trapezium. This distance is area of this trapezium. This is 1 kilometer anyhow given. So what is area of this trapezium? Half into 60 plus 20 into 2/3. That is 80 into 2/3. But you have to change anyhow. Okay. Plus that distance, half into 20 plus 60, that is 80 into 4/3. So that is how much? 40 into 6/3. This is 40. If I take common, okay. here also 40. So 40 into 2 by 3 plus 4 by 3, that is 6 by 3, 2. So 80 kilometers, some distance, okay. So this is 80 kilometers, here and here put together. It has taken how much time? 2 by 3 plus 4 by 3, that is 6 by 3, means 2 minutes it has taken. But if there was no repair, how much time it will take to travel this distance? 80 kilometers. It could have traveled with 60 kilometers per hour speed. Then what is time taken? 80 by 60. That is, it is only 4 by 3 hours. Okay. Now how much time it has taken to travel this distance, and this distance is 2 minutes. Now how much time it will take? 4 by 3 minutes. Okay. So what is extra time? Is 2 minus 4 by 3. That is 2 minus 4 by 3 is 2 by 3 minutes. Okay. So from here to here and here to here it has taken 2 by 3 minutes extra. And here also 1 kilometer to travel, how much time it has taken? If it has traveled with 23 minutes. If it could have traveled with 60, it could have taken 1 minute. So what is extra time it has taken? Is 2 minutes. So what is total extra time it has taken? Is 2 minutes plus is 2 by 3 minutes. That is 8 by 3 minutes. Okay, followed. Next, this question. A glass windscreen whose inclination with the vertical can be changed is mounted on a cart as shown in the figure. The cart moves uniformly along the horizontal path with a speed of 6 meters per second. At what maximum angle alpha to the vertical can the windscreen be placed so that raindrops falling vertically downwards with velocity 2 meters per second do not enter the cart? Now raindrops are falling vertically downwards. With what velocity? So this is velocity of rain is 2 meters per second, and car is going horizontally towards right with a velocity of 6 meters per second. So what is velocity of car or velocity of rain with respect to car? Is nothing but velocity of rain minus velocity of car. Velocity of rain minus velocity of car. So it is resultant of these two vectors, that is relative velocity of rain with respect to car. It will be magnitude, you can find anyhow, but magnitude is not required for this question. Direction you have to find. So resultant will be somewhat like this. Making how much angle with vertical? Tan alpha equal to 6 by 2. If this is theta, let us say. Tan theta equal to 6 by 2, that is 3. So raindrops are falling in what direction? Making an angle of tan inverse 3 with downward vertical. Okay. Now if those raindrops collide this windshield normally, then they do not enter the car. Okay. If this angle with vertical decreases, they will enter the car. If this angle with vertical increases also, they do not enter. So what is the maximum angle at which they can fall so that they do not enter the car? They should collide normally. So they should collide normally means, what is this angle? Alpha. So this is also alpha. So this is 90 minus alpha. So how much angle the raindrop should make with vertical? 90 minus alpha. Okay. And if it makes more angle than that also, they do not enter. Okay. More angle than 90 minus alpha with vertical also, they do not enter. But if it is lesser angle, they will enter. Okay. So 90 minus alpha you should find. How much angle the raindrops are making with vertical? 90 minus alpha, or with horizontal alpha. So this I have measured with vertical actually. With horizontal means tan inverse 1 by 3 I'll get. Okay. So tan alpha equal to 1 by 3 I'll get. Horizontal 1 by 3. So tan inverse 1 by 3. Next question. An airplane is observed by two persons traveling at 60 kilometers per hour in two vehicles moving in opposite direction on a straight road. To an observer in one vehicle, the plane appears to be cross the road track at right angles, while the observer in the other vehicle, the angle appears to be 45 degrees. At what angle does the plane actually cross the road track, and what is its speed relative to ground? Now let us say this is road track and this is A, this is B. One car is going like this with 60 kilometers per hour, let us say U. Other car is coming like this with 60 kilometers per hour only, that is also U. Now with respect to this car, plane is appear to be going like this across the track with respect to one car. Then with respect to other car, it is appear to be going making an angle of 45 degrees with track. 45 degrees with track or with this AB, it is same anyhow. Okay. So what is velocity of plane with respect to this car? Is velocity of plane minus velocity of car. Let us say velocity of plane is in some direction like this. Let us say V, making an angle theta with track. Okay. Then what is velocity of the plane with respect to car? This first car. It is resultant of V and negative of this. That is U, you should reverse and add it to that. Then with respect to a person in the first car, he is seeing that plane is crossing the road like this, across, means resultant of these two is in this direction, means x component should be 0. So V cos theta equal to UL. Now we will see with respect to this car. With respect to this car, what is velocity of plane? Is resultant of V and negative of this vector. What is negative of this vector is same in magnitude but opposite in direction. So V and U resultant. Resultant of these two is relative velocity of this plane with respect to this observer, which is in what direction this observer is observing. Plane is crossing at an angle of 45 degrees. So resultant of these two should make 45 degrees with x axis, means x component of the resultant relative velocity should be equal to y component of relative velocity. What is x component? Is u plus v cos theta is equal to v sin theta. Okay. But what is v cos theta is u from the first equation. So what is v sin theta? 2ul. Okay. So if I divide these two equations, tan theta equal to 2 will get. So in actually plane is crossing the track in what direction? At an angle of tan inverse 2 with track. Okay. And with what speed? What is velocity of plane relative to ground? Means absolute velocity. That is V you should find. So square and add. If I square and add, what do you get? V equal to root 5 u will get. But u is 60 kilometers per hour. So this is root 5 into 60. Now next question. Two ships A and B originally at a distance d from each other depart at the same time from a straight coastline. Ship A moves along a straight line perpendicular to the shore, while ship B constantly heads for ship A, having at each moment the same speed as the latter. After a sufficiently great interval of time, the second ship will obviously follow the first one at a certain distance. Find that distance. Now let us say two ships are separated along the coastline like this. Now ship A, first ship is at origin, let us initially, and second ship is at some point A. So this is first ship here, this is second ship, and both of them are moving with constant velocity, but first ship is going with constant velocity along the shore like this. Let us say velocity of first ship is u or v in this direction. Speed of second ship is also v, but it is not constant. Velocity direction is not constant. Its velocity is in such a way, its velocity is always directed towards the position of ship 1. So ship 1 is going like this with constant velocity, but ship 2 is going like this, where its velocity is continuously changing its direction. Okay. Then when finally the ship 2 comes onto this line, ship 1 will be somewhere here. Then what is this separation they are asking? So in between, let us say when ship 2 is somewhere here, after some time, its velocity is along the tangent, V, and this angle is theta, let us say, with x-axis. Then this is the position of ship 1 at that instant, moving in this direction. This angle is also theta. Then this is B, this is C, let us. Then what is approach velocity of ship B with respect to ship C? It is nothing but V minus V cos theta. V minus V cos theta. Okay, this is V, this is V cos theta. V minus V cos theta. What is approach velocity? Rate at which separation changes. Rate at which separation changes. Now, if I integrate approach velocity, what do you get? We will get initial separation minus final separation. What is initial separation between these two ships? Is d. Finally, when ship 2 comes onto this x-axis, let us say ship A is somewhere here, where separation is some x naught I will take. So, if I integrate approach velocity, we will get how much distance between the two particles has decreased in a time t. So, assume this ship A has taken capital T seconds to come to this point. In that time, ship 1 has travelled from here to here. Okay. Now, if I integrate this from capital T, 0 to capital T seconds, with respect to time, we will get how much separation has decreased. How much separation has decreased means initial separation minus final separation, that is d minus x naught. Unless its speed is greater than this, separation they cannot meet, separation will become 0 then. If its speed is equal to this or less than that, when it comes on to this line of motion, there is still some separation between them. Now, if I integrate this, what is first term I will get? V capital T minus second term V cos theta dt, that is equal to d minus x naught. But how do you find this integral V cos theta dt? Now, V cos theta is nothing but x component of velocity of ship 2. So, if I integrate x component of velocity, you will get displacement along x axis in capital T seconds. So, integral 0 to t V cos theta dt is displacement of this ship 2 along x axis in capital T seconds. That is how much from this figure? It is displacement of ship 1 minus x naught. In the same time, ship 1 has travelled from here to here. So, what is displacement of second ship along x axis in that time? Displacement of ship 1 minus x naught. What is displacement of ship 1 is V capital T. So, this is nothing but V capital T minus x naught. So, what is integral V cos theta dt from 0 to capital T? Is Vt minus x naught. So, if I replace this with Vt minus x naught, what do you get? Vt minus of Vt minus x naught equal to d minus x naught. So, if I simplify this, you will get x naught equal to d by 2. Vt cancels, so you will get x naught equal to d by 2. Okay. Next question. A projectile is to be thrown horizontally from the top of a wall of height 1.7 meters. Calculate the initial velocity of projection if it hits perpendicularly an incline of angle 37 degrees, which starts from the ground at the bottom of the wall. The line of greatest slope of incline lies in the plane of motion of the projectile. Okay. Now, this is an inclined plane. What is this angle is 37 degrees. And the bottommost point of the inclined plane is below the wall. So, the particle is projected from somewhere here horizontally. Height of this wall is 1.7 meters. And it is projected horizontally with a velocity of some u, let us say. Then it has to collide the inclined plane normally, perpendicularly. Okay. Now, assume it collides the inclined plane normally after t seconds. After t seconds. So, at that time, what is its velocity? Let us say v. Then, if I draw horizontal here, what is this angle is 37 and this angle is 53 degrees. So, what is horizontal velocity is v cos 53. V cos 53, that is 3v by 5, which is equal to initial horizontal velocity. So 3v by 5 equal to u, that is first equation, and by the time it goes from here to here, it has acquired vertical velocity. What is vertical velocity it has acquired is gt. What is initial vertical velocity? 0. After time t, what is vertical velocity? Gt. That is nothing but v cos 37. V cos 37. So 4v by 5 equal to gt, that is second equation. Next, by the time it comes from here to here, what is horizontal displacement? Is ut. What is vertical displacement? Is half gt square. Half gt square. Okay. Now, if you consider this triangle now, this is ut and this is h minus half gt square. So tan 37 is equal to h minus half gt square by ut. What is tan 37? 3 by 4 equal to h minus half gt square by ut. Okay. What is h given? 1.7 meters. Okay. And what is u? 3v by 5. What is v? 5gt by 4. Okay. So substitute in place of u 3v by 5 and v is 5gt by 4, cross multiply, you will get t. Okay. That you can simplify, I think. Initial velocity you have to find. Once you know t, you can find v and u also. Okay. If I divide these two, you will get u in terms of time. Okay. If I divide these two, what do you get? 3 by 4 equal to u by gt. What is u? 3gt by 4. So here what do you get? 3gt square by 4. So here 9 by 16 I will get. So 9gt square by 16 is equal to h minus half gt square. Okay. So if I take half gt square common, you will get 9 by 8 plus 1, that is 17 by 8, that is 1.7. From there t value you can find. Here if you want, you can write total velocity makes how much angle with horizontal here? 53. So tan 53 equal to vy by vx also you can write. Okay. Vx is u, vy is gt. From there directly you will get, instead of writing two equations. Okay. Next, a particle is projected with a velocity of 2 root ag so that it just clears two walls of equal height a, which are at a distance 2a apart. Show that the time of passing between the walls is 2 root a by g. A particle is projected from ground, then it follows a path like this and comes here. This is O, this is A, let us say. With what velocity? U is equal to 2 root ag. In between it crosses two walls, each of height a, but separation between the two walls is 2a. Then what is time taken to cross the two walls? Let us say this point is B, this point is C. What is time taken to go from B to C, they are asking. So if you know velocity here and angle of projection here, what is time taken to go from B to C, we can find. Directly 2u sin theta by g you can write. Now whenever they give initial velocity and this height, then how do you find velocity at any point which is at height h above that initial velocity? Directly you can use energy conservation. Now initially when we start kinematics topic, we don't do this by energy method, because energy we did not teach at that time, we did not, okay, in kinematics. Then we can use equation of projectile and solve, or you can take motion from topmost point and do also. Now because energy is over, here velocity is given and height is given, then velocity at any point you can find by using energy conservation. So if velocity here is v and if this angle is theta, let us say, then what is if I do energy conservation from here to here, loss in kinetic energy equal to gain in potential energy. What is loss in kinetic energy? Half m u square minus half m v square. equal to gain in potential energy, that is mgh. Okay. What is V square? Is U square minus 2gh. U square minus 2gh. So in this case, what is velocity here? V. Okay. So V equal to under root U square minus 2gh. What is U square? 4ag minus h is a, so 2ag. So what is velocity there? Is root of 2ag. That is velocity at that point. Now from here to here, what is range? If I consider motion from B to C, what is range? 2a. Then what is time taken from B to C, they are asking. Now you know velocity here and angle of projection here is theta if I consider. Then range is 2a, you know. Then what is range formula? V square sin 2 theta by g, that is equal to 2a. Then you can find theta. V square means 2ag and sin 2 theta by g is equal to 2a. Okay. So this cancels, 2a cancels, sin 2 theta is 1 I will get. So 2 theta is pi by 2 or theta equal to pi by 4 I will get. So at what angle it crosses the first wall is 45 degrees with horizontal. And from here to here, what is time taken? Is 2v sin theta by g, that is 2 into root 2ag into sin theta, that is 1 by root 2 by g. Okay. So root 2 cancels, you will get 2 root a by g. Okay. That is the time taken to go from here to here. We can use equation of projectile also if you want. So next question. A stone is projected from the point of a ground in such a direction so as to hit a bird on the top of a telegraph post of height h and then attain the maximum height 2h above the ground. If at the instant of projection the bird were to fly horizontally with a uniform speed, then find ratio between the horizontal velocities of the bird and the stone if the stone still hits the bird while descending. Now let us say stone is projected from some point O on ground with some velocity u, then it follows a path like this and reach ground somewhere here. But it is projected to hit some bird which is at a height h above ground, so somewhere here, to collide that. Means stone is projected to pass through this point. But as soon as the stone is projected, this bird starts moving horizontally. Let us say it starts moving horizontally. But stone still has to hit the bird. Means by the time bird comes here, stone has to reach this point from here. So let us say B. So if stone has to still hit the bird, it has missed at A, it has to hit the bird at B. Okay. So let us say this is x1, this is x2, and this is also x1 anyhow. Now in a projectile motion, for every one vertical displacement there are two horizontal displacements whose sum is range. So what is x2 plus x1 is range of the projectile. So what is x2 plus x1 is range, that is u square sin 2 theta by g if this angle is theta. What is asking is find ratio between the horizontal velocities of the bird and stone if stone still hits the bird. So by the time bird goes from A to B, stone should travel from O to B in the same time. So because they are taking same time to travel from A to B bird and O to B stone, the ratio of horizontal velocities is nothing but ratio of horizontal displacements. Okay. Ratio between horizontal velocities of bird and stone. So what is horizontal displacement of the bird? x2 minus x1. By horizontal displacement of the stone is x2. Okay. But what is x1 plus x2 is u square sin 2 theta by g. And okay. Now if I write equation of projectile now, what is equation of projectile? Y equal to x tan theta into 1 minus x by r. That is equation of projectile. Okay. Okay. So in this equation, if I put y equal to h, we should get x equal to x1 and x equal to x2. For every one vertical displacement, there are two horizontal displacements. So if I put y equal to h and simplify this, what do you get? X square tan theta by r minus x tan theta plus h is equal to 0. This is the quadratic equation I will get. What are the roots of this equation? Are x1 and x2. What is sum of the two roots? Is r. What is product of the two roots? x1, x2 is c by a. So what is x1, x2? Is c by a. What is c? Is h, and a tan theta by r. So h by tan theta by r. So that is x1, x2. Now what I want is ratio of horizontal velocities is nothing but ratio of horizontal displacements, that is x2 minus x1 by x2. Now from these two equations you can find x2 minus x1. What is x2 minus x1 whole square? Is x2 plus x1 whole square minus 4x1 x2. What is x2 plus x1 whole square? Is u to the power of 4, that is r square, minus 4r h by tan theta. Okay. But what is given in the question? Another information, and then attain the maximum height of 2h. So it misses this bird here, but later on goes to a maximum height of 2h. But what is the relation between maximum height and range for a projectile? R equal to 4h cot theta. But what is h here? 2h. So this is 8h cot theta. Okay. So what is small h? R by 8 cot theta. Okay. So small h cot theta, if I take tan theta to numerator, you will get how much? Small h cot theta is equal to r by 8. So you can replace this with r by 8. So r square by 2 I will get. So this is nothing but r square by 2. So what is x2 minus x1? Is r by root 2. So x2 plus x1 is r. And what is x2 minus x1? Is r by root 2. From here we can find x2 if I add these two. 2x2 is equal to r into 1 plus 1 by root 2. x2 minus x1 also you know. So what is ratio of horizontal velocities? Is x2 minus x1 by x2. Followed?